Okay, we are now talking about 6-1 from the 2014 pre-calc textbook, which you do not have, but we have the study guides for. It is entitled Multi-Variable Linear Systems and this is the good part, row operations.
Oh, yeah.
Oh, row operations, how I love you.
Aren't you married?
I would, but I can't get the tax write-off if I marry something like that, so.
Shoot.
Yeah, that's a flawed system.
Totally.
All right, so our objective is to solve systems of equations using two different methods. Gaussian elimination and Gauss-Jordan elimination. Gaussian and Gauss-Jordan. Gaussian named after Gauss, a pretty famous mathematician, and Gauss-Jordan named after both Gauss and Jordan. Jordan, who built on the Gaussian elimination method, and then honored Gauss by continuing the name, or somebody else did, I'm not really sure. So, here's what we're going to do this. We can use matrices to solve systems of equations. You've been doing systems of equations for quite some time. You did them in Algebra 1 a little bit, then you did them again in Algebra 2 a little bit more. Now we're going to learn a whole new way to do them. And this is the computer method for doing them, the matrix way of doing them. So let's talk about the Gaussian elimination method. Gaussian elimination method. I'm going to throw a whole bunch of vocabulary at you that you might not know yet, and then we'll talk about what they mean. So the Gaussian elimination method, in this you use row operations on the augmented matrix. That's another thing that we'll have to talk about. On the augmented matrix to put it into what we call row echelon form. Another thing that we're going to have to talk about.
I don't know who's playing music, but I can hear it. Is it you?
Can you hear it at home? So we're going to do just one example today, and it's going to take us most of the time, because we got to talk about what all these things mean and how we get there. So, let me put it down for right now, and we'll talk about the strategies, and then we'll do it afterwards. We're gonna solve by Gaussian elimination. And here is the system: x minus 2y plus z equals -1 and 2x plus y minus 3z equals -7 and 3x minus y plus 2z equals 0. That is our system of equations.
Are we not gonna define these things first?
I'm going to define them as I kind of work through the strategy for doing this, because the strategy and the vocabulary fit together. Okay? So, the first thing we have to do is create the augmented matrix. And I'm going to show you what the augmented matrix looks like, and I think it'll be pretty self-explanatory. So we're going to go from this to this augmented matrix form, and the way you go to the augmented matrix form is you have your x's, y's, and z's lined up. You've got to make sure they're lined up. In this case, they already are. And you simply put the coefficients. So this is 1, -2, and 1. Somebody's really, Catherine, is that you with your, thank you. So this is the x column, this is the y column, this is the z column. And then we put a little bar, and we put the answer column. And that's how you make the augmented matrix. Okay? So then we do the next one, 2, 1, -3, 2, 1, -3, and in the answer column, -7. What's it? Yeah. And then 3, -1, 2, and 0. And that is our augmented matrix.
Is that what you meant by the absolute value sign meant something? Or
No,
is there?
no, that'll be still in the future. This is just a bar separating the x, y, z columns
Okay.
from the answer column.
All right.
That's a good question. So that's what we mean by augmented matrix. Now, our goal. Let's talk about our goal. Our goal is to go to row echelon form. Row echelon form. And row echelon form looks like this. It'll be a 1 for the first row, a 1, then some number, then some other number, then a number in the answer. Row 2 is a 0, a 1, and then a number, and then a number in the answer. And row 3 is 0, 0, 1, and a number in the answer.
What is echelon?
Row echelon form, that is this form right here.
That's 1 A, B, C in the top?
Well, yeah, 1, A, B, C. A, B, C are just variables for
I was just
missing
checking to see
numbers.
if it was a 1.
Yes, yes. These are all 1s in the diagonal here. These are all 1s. And before the ones are all zeros, after the ones are all numbers. And this is what we call row echelon form. Okay,
Why,
so
why do we need to get that?
I'm just about to get there. So this is our X, Y, and Z columns, right? They will still be our X, Y, and Z columns. What this does, let's say it this way, row echelon form gives the answer for Z, or whatever the last variable is. Okay? Think about what we're missing out of here. We're always missing the variables, right? But what this last row says is 1 times Z, which is just Z, equals whatever number is there. So if you get it in row echelon form, what you're doing is you're getting the answer for that last variable. And because you've got the answer for the last variable, you can go up here and you have Y times DZ equals E, and you can plug in Z, and you can figure out Y. And once you have X and Y and Z, you can plug them in here and figure out X. So you start from the bottom and work your way up, and that's how you get all the answers. But you must go, and this is the part that's going to be tricky, you must go from the augmented matrix into the row echelon form matrix. And that's the part that we have to do what are called row operations for. And so most of the rest of the time is going to be spent on figuring out how to do and what row operations are, because this is the difficult part of this section is the row operations part. It's also the fun part. Let's stop, please.
Oh, sorry.
And we'll go on